right, so we're going to be continuing our work now with derivatives. And what we're going to look at are a couple of rules to make things much simpler in terms of finding the derivative of a function. These will be the constant rule, the power rule, and the sum and difference rules. So let's get right to it with the constant rule, and it says the following. If we have some function f of x that equals c, and that's a constant c. Now that could be the number 8, -12, 0. If you just have a function that is just a constant, well, then the derivative of that constant function is just 0. So now if we think about it, hopefully that is logical. All right, think about the graph of this and why it would make sense that the derivative would be 0. So hopefully you kind of picture this in your head. So if we have f of x equaling some constant, let's just call this maybe 5, all right? So if we have f of x equals 5, we have a horizontal line. Now, the derivative is the slope of the tangent line. So if we have a horizontal line, that's the function, and then the slope of the tangent line is just going to go right alongside that function, and that's going to be 0 as well in terms of the slope. So that's why it doesn't matter if it's up here at 5 or down here at -3 or at 0. If you're dealing with a constant, then the derivative will be 0. So if we look at a few other examples here, we have some functions here and then the derivatives. And it's really just, this is a good way to look at some of the other notations. So if we had y equals 7, we could say that dy dx equals 7. We could also say that y prime equals 7. Here we have f of x equals 0. Well, that's just the x-axis. And then we could say that f prime of x is also 0, and that just means that it's the tangent line. The slope of the tangent line is 0. We could have the function be s of t equals -3. So then s prime of t would be 0. Okay, so very straightforward. Constant rule is pretty simple. If it's a constant function, then the derivative will just be 0. Okay, now for the power rule. And we'll be using this quite a bit, and it's very helpful. So when we first started looking at derivatives, and we used the formal definition of it, to find the derivative was a pretty long process using a lot of algebra. But in the end, what happened was the following. All right, if we had this function here, we went through that long algebraic process, we found that the derivative was x squared plus 3x. The derivative was 2x plus 3. And all right, then if we looked at another one here, we had 7x minus 5. That was the function. We did a bunch of work and found out that the derivative of that was just the number 7. It wasn't a function, it was just 7. And then finally, if we had this function here, x cubed plus 4x minus 8, we figured out the derivative was 3x squared plus 4. Now, in looking for some patterns and perhaps some shortcuts, it does look like there's something going on here, okay? And this is going to lead us to the power rule. So let's take a look at what it says. So if we have some function that has x raised up to some power, to find the derivative, it's going to look like this. Okay, and essentially what it's doing is it's taking this n, whatever the power is, multiplying it. We're putting it in front. That's going to be the new coefficient, or multiplying by whatever number's there. And now the new exponent is we're going to take 1 away from that. Okay, so we saw that happening in the other examples. And let's take a look at a few more. So here we go. If we have something like this. All right, so our first example here we're going to look at is, let's just say we had x cubed. All right, well, the power rule says we're going to take this exponent and multiply in the front, so that's going to turn into 3. And then we'll just have our x here. But now, instead of it being x cubed, we're going to take 1 away from it. So it's going to be x squared. Okay, so if we have our function here, and then this is going to be our derivative over here. Okay, so if we have x cubed, then the derivative of x cubed is going to be 3x squared. Okay, that's using the power rule. Let's try another couple of these. what if we had something like 7x squared? Okay, think about it or pause the video and try it on your own. But it looks like what we're going to do is we're going to take this 2 times the 7, so that's going to be 14, and then we're going to say x, that goes to the 2 minus 1 power, so 2 minus 1 is just 1, so we'll just leave it like that. Okay. Next up, let's go with something like this, a little bit trickier. Let's go with the cube root of x. Okay, now to do something like this with the power rule, it's a good idea to rewrite it first so it's x to some power. So the cube root of x, thinking about it in terms of a power, well, that is really x to the 1/3 power. Now we haven't found the derivative yet, we've just rewritten it. So in terms of the derivative now, well, let's go through the process. We're going to say 1/3 times the x. Okay, and now we have to take away 1 from 1/3. Okay, so 1/3, if we take away 1, then we're going to get negative 2/3. Okay, now that is a little bit of a mess, so we want to clean that up. So let's think about this. We're definitely going to have a fraction here. Now, in the numerator of the fraction, we'll just have this 1. In the denominator, we'll have the 3. And now this x being raised to the negative 2/3 power, that's going to bring it down to the denominator. So that's going to be, we'll have x squared, and it'll be the cube root of it. So it's going to look like that. Okay. So yeah, if you get something like this, it's a good idea to rewrite it first. So it's x being raised to a power, so we can clearly see what the power is, and then we can use the power rule from there. Okay. We'll do one more. What if we had something like this? 5 over x squared. So think about that process. Little hint, you should probably rewrite it first. So we can rewrite 5 over x squared as 5 being multiplied by x raised to the negative 2 power, right, when it's down there. Okay, so now that it looks like this, we can use the power rule. Multiply the negative 2 times 5 and get negative 10. And now be careful here. I'm going to take away 1 from negative 2. So that goes down to negative 3. Okay, so we have negative 10 times x raised to the negative 3rd power. So it's going to turn into a fraction again. The negative 10, that will remain in the numerator. Now the x to the negative 3 will bring that down and have it be x to the positive 3. All right, so those are just a couple different ways we can see the power rule work out. And we'll get more practice in class. But for now, though, let's just move on to the sum and difference rules. And here's what this says. We won't spend a ton of time on this because I think it's pretty intuitive. Okay. And what we're really just saying here is this. If we have multiple things being added together, we can kind of treat them each as their own function. So if we had something like f of x plus g of x, and what's going on here is, so these are the original functions, and this is saying, okay, we want to find the derivative with respect to x. Well, what we can do then is find the derivative of f and the derivative of g and just add them together. Okay? And a similar thing's going to happen if we had subtraction. Okay? And all that really means, if that looks complicated at all, when you see an example happen, you'll notice it's really not too bad at all. So an example of sum and difference rules could be something like this. So if we have A, we're going to say, let's just say we had the following: x cubed minus 4x plus 5. Okay, and let's just say we'll call this f of x. I know in the definition we were saying f and g, but for now we're just saying this is f of x, and we can just look at this as, you know, multiple functions being added together. So really then, if we go f prime of x, really just what we're doing here is we're gonna find the derivative of each one, and then add them up. So so that first part, x cubed, we'll say that that's going to be 3x squared, and then over here we have minus. Now let's think about this. This is x to the first power So that's really just going to be 1 times the 4. And then, so that's going to be 4 there. And now x is going to be raised to the 0 power, right? Because we're going to take away 1 from 1. So x to the 0 power is just 1. So that leaves us with just minus 4 with no x. And then this 5, let's remember, that's a constant. So the derivative of that 5, well, if it's derivative of a constant, it's just 0. So we could say plus 0 to start off with, but then we'll just kind of get rid of it. Okay, so our derivative of this function here is going to be 3x squared minus 4. So that's what the sum and difference rules is talking about. So it's kind of it looked a little more complicated in terms of the actual definition of it, but it's really not too bad. And let's just take a look at this last one now and give us some practice with rewriting stuff. So let's go with negative x to the 4th over 2 plus 3x cubed minus 2x. All right, that's our g of x. And if you want to pause the video and give this a shot, you can, or you can just follow along with me now. So really, we can think of this as 1/2, right? Negative 1/2 x to the 4th. So now I'm going to multiply the 4 times the front. So that's going to be, we'll say that's negative 4x to the 3rd, because we're going to take 1 away from the exponent there, and it's still over 2. And then we'll say plus, now we're going to take this 3 times this 3 here, so that's going to be 9x squared, okay, because we took 1 away. And then this minus 2x, this is similar to that 4x earlier, so that's just going to be minus 2, because we're taking a 1 here times negative 2, and then we are decreasing the exponent 1 by 1, which brings it down to 0. So there we go. And then you just always think to yourself, can I clean this up a little bit more? Yeah, let's take care of this negative 4 over 2. So that's going to be negative 2x cubed plus 9x squared minus 2. Okay, so that is our final derivative there using the sum and difference rules. So really it's just kind of a combination of using the power rule with multiple terms. Okay, now let's not forget that what we're doing with all this is now the way to find the slope at certain points on a function. It's at a curve, and we'll be able to plug values of x into this to figure it out. But we'll get into that more in class when we meet. And if you have any questions at that point, any of this, you can let me know. All right, thanks.